foldable, you'll see two names, domain on one side, range on the other. So you can just take your foldable and just fold them to the middle. Okay, that's all you'll need to do for this one. And on this particular lesson, we're going to be looking at the domain and ranges for some of the graphs that you're going to see inside of the foldable. So we're going to start with the domain side first. Okay, the domain side first. So let's just recap. Domain are your X values. So now you're going to be using a different name for X. We're going to call them domains. When you're looking at a graph and it says you're going to scan the graph to include all the values on the graph, moving from left to right, because obviously this is your x-axis here. So if I ask you what are the domain values and you don't see any dots up here, so this is, this first one right here, we call that a continuous graph. There's no way possible that you could actually list every single coordinate on that graph, because coordinates can also have coordinates not just with integers and whole numbers. You can have halves and fourths and everything, so there's no way possible. So when we are listing a domain for these types of problems, we have to put them in set builder notation. So that means that we have to look at them and give a range of what's going on. Now, when you're looking at a parabola, which is the first one, okay, remember that curve actually has a name. I'll put it up here again. When you're looking at a parabola, if a parabola goes up or down, okay, it's going to be all real numbers, and that's just a fact. Okay, all reals. Now, when we write all reals, we'll say X such that X is an element of all real numbers. Because if you notice on a parabola, again, you see the arrows there, it will continue to go up. And as it continues to go up, it's going to cover the entire x-axis. Okay, as it goes up, it's going to obviously get wider, 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 and wider. And so it'll eventually cover the entire x-axis. So we just say all real numbers. Okay. Now, when we're looking at the circle in number 2, you can see there's a hot, from left to right, we can see there that it stops here and over here. So we actually have a range of x's. We can't still list every single x value that's there because there's some that are in between. So we give a range. So it goes from -1 to +5. And of course, to complete the set builder notation, we say X such that, and we start with our smaller number like we did in our last unit. -1 is less than or equal to X, which is less than or equal to 5. Because again, it is only going from -1 to 5 on the X-axis. Okay, let's take a look at question number 3. So in question number 3, notice the X values do not begin until -1, right here. And then it obviously, as the line is pointing to the left, your X's are going to get smaller as you go in this direction. Okay, so as this continues to go up, then that means it's covering the X-axis to the left. Thus you see X such that X is less than or equal to -1. So let me stress that this point, the question was, if this dot had been open, we would have just had X such that X is less than -1. We would not have put the equal sign. Because in the original problem, the dot is closed, that's why we have the equal sign. Okay. All right, let's move on to question number 4. And again, we're only looking at the domains right now. So we're only moving our eyes from left to right. So in this case, notice that the x's start back here. Okay. And then the x's get bigger as this parabola starts to open. So since it starts at -3, it gets larger as it opens up. Okay, we're back here at -3. Then you have x such that x is greater or equal to -3. All right, now we're going to look at the ranges, which are the y values. So let's move on to ranges. Now, when you're looking at ranges, which are your y values, you're looking bottom to top. Okay, from bottom to top. So in this case, you see again, as this continues to go out and it gets larger and larger and larger, you're going to have y such that y is an element of all real numbers. Because now the y's is going to cover, again, from bottom to top. We're not looking left to right anymore because we're talking about the y values. Okay, y to the sky. Okay, that's that axis that's vertical. So as that continues to open up, it's going to be covering the y-axis. So here's a circle, but again, we're not looking left to right this time. We're looking bottom and top. So you want to get the lowest y and the highest y. So this is where we're going to have a range of numbers, okay, because it's a circle. So in this case, your smallest y is at -2. Your largest y is at +4. And then you just put that in set builder notation. So you start with your smaller number, always those less than equal signs because it's continuous, the circle, there are no breaks in it, and to the larger number. And that's how you put it in set builder notation. All right. All right, next one. So again, we're just looking at the y values. So we're starting right here at 2. And then the y's actually, as this graph continues to go, it's getting smaller. So y such that y is less than or equal to 2. Now, if that had been an open circle there and not a closed dot, we would have just used less than without the equal sign. Okay. All right, in question number 8, here's my y value right here. So the y starts at what number? Okay, at 1. And then what happens to the y as this graph continues to extend out? The y's will get larger or smaller? It'll get larger. So your answer is y such that y is greater or equal to 1. Okay, because it starts at 1 and continues to get larger. We're going to continue on pages 5 and 6 in your new math packets. So we're going to be talking about discrete graphs. That means graphs that are not connected, and the continuous graphs where you actually form some type of curve. Okay. So everyone should be on page 5. All right, now on page 5, it says, they give you like a little scenario at the top about lemonade served in a souvenir cup at a festival, and then they give you the equation. Here's the function right here. It says graph the discrete function with the domains of 1, 2, 3, and 4, and write the domain and ranges in set builder notation. Now, anytime it's a discrete function, we're not going to connect the points. Okay, so this is where you do not connect. So let's write up here, do not connect. So basically what you're doing is you're making a t-table with these values 1, 2, 3, and 4, and you're just going to pair them up with the y values, and you're just going to plot the points. After we do that, then we're going to list our numbers in numerical order for our domains and ranges, right? So we're going to grab the graphing calculator, and we're going to put in this function right here, because we can have the calculator give us the y values. So 2x plus 1. All right, so you're going to hit your y equals key. You're going to put in 2x plus 1. And then we're going to go to the table. So we're going to hit second graph. And then we're going to fill in the y values. So we're going to have 1 being paired up with 3. 2 is paired up with 5, 3 is paired up with 7, and 4 is paired up with 9. So you're just going to go back and fill those numbers in. And then we'll just plot them. So we're going to go over 1 and up 3, over 2 and up 5, over 3 and up 7, and over 4 and up 9. Okay, and that's all you do. You don't connect these because it's a discrete. That means just very particular points that we're looking for. So when we list our domains and ranges, we actually list each individual point because it's not connected. So we're going to say x such that, and this is x equals 1, 2, 3, 4. Okay, because these are individual points. They're not something connected, so there's nothing in between. There's just 1, 2, 3, and 4. Okay, give it a second. Let's finish the ranges. So for the ranges, we'll have y such that y equals 3, 5, 7, and 9. Number 2 is a continuous, but we've done a lot of continuous. So let's just go down to 3 and 4. So in number 3, they give you a graph, and this is a discrete graph. How do I know it's discrete? It's not connected at all. So what we'll have to do is write down all the coordinates first. So we got to have all the coordinates written so we can actually determine all the x's and y's. So this coordinate here is going to be what? 2, 4. Is that right? Okay, and then I'm going to move down over here to the third quadrant. That looks like -4, -2. Is that correct? All right, and then this one is -2, -2. And then this one over here is what? 4, -6. All right, so what we want to do, if any of the numbers repeat, we don't repeat them. Okay, so let's write that down as well. Do not repeat numbers. You don't repeat. If it's repeated in the x or the y, we don't repeat them. Okay, so put a little star there for that. Now, we do need to put this in numerical order. So let's start with the x's. So the smallest x, and we're going to say x such that x equals -4, -2, and what else do we have? 2 and 4. Very good. And then for the y's, it'll be y such that y equals, what are my y values? What's the smallest y value? -2, -6, right? And then -2, and what's the next one? 4, and that's it. Okay, again, we do not repeat any numbers. So if they're repeating, we don't write it twice or 3 times. We don't write it. Okay, let's look at question number 4. Now, question number 4 is a continuous graph. So we can't list every single coordinate on a continuous graph. Okay, we just did that on the foldable. So let's do our x values. Who remembers what I told you about parabolas if they go up or down? What do we say for the domains? All reals. Very good. You don't even have to just think of it. Okay, it's going down. As Outland said, if it goes up or down, it's going to be all reals for your domains. So x such that x is an element of all real numbers. Okay. Now, we can't say all reals for the y's. Because notice, I don't even have any y values up here. So where do the y values start? Right here at 3. Very good. So that's where your y values start at 3. And then what happens to the y values as this parabola goes down? It gets smaller. So we're going to say y such that y is less than or equal to 3. Okay, since I've already done a circle example, we're going to go down to the triangle example. That's one we haven't done yet. So take a look at the triangle. So I'm going to do 7 and 8 because we've done one very similar to 5 and 6. So look at question number 7. So what we need to pick out here, again, is going to be a range of numbers because I have a large x and a small x, and same thing for my y's. So how far do the x's go out? So let's look from left to right. Okay, right here for the x's and right here. So those are my ranges for the x's. Maybe I will say my interval for the x's. I don't want to use the word range. So when I write this, I'm going to say x such that, and this is at -4. -4 is less than or equal to x, which is less than or equal to +4. Okay, that is my interval for my ranges. It goes from -4 to +4. Okay, now, we will be eventually also putting these in interval notation. And that was from our last unit, so we know how to write it in interval notation and set builder. Okay, today we're just going to concentrate on the set builder. For your ranges, okay, we need to pick the lowest y and the highest y. Okay, lowest y looks like it's right here. Is that right? And what's the highest y? 4. Okay. So when I write my ranges, I'm going to start with the smallest or the smaller number, which is what number? -2 is less than or equal to y, which is less than or equal to 4. Number 8. Okay, in question number 8, good thing about all of these slant lines is going to be all reals for both. That's a good thing. So whenever you see lines that are slanted like this, or even if they're going in the negative direction, and you might even want to draw all these lines, because even if they're going in positive direction or negative direction, okay, all of those diagonal lines will be all reals for both. X such that x is an element of all real numbers, and y such that y is an element of all real numbers. Okay, so anytime it's a diagonal line, you're going to have the same thing. Okay. What if it's a vertical line? That's a good question. So I'm going to draw a vertical line here because I didn't have an example, and I'm going to put it at 4. Right? All right. I have a vertical line here. What will be my x's at 4? Wait, yes. So my domains will be what? Just x equals to 4. It doesn't change, right? Because x, when there's a vertical line, that is the equation, and the x's are the same every single time. Let me ask you this question. Are vertical lines functions? No. Okay, you put a vertical line test on a vertical line, of course it's going to touch it at every single point. Okay, so that is not a function, right? What will the y values be for a vertical line? All reals, right. Y such that y is an element of all reals. So that would be, just add that some kind of way for a vertical line. Your x's do not change for vertical lines. Now, what if you're given, and you will be given this, what if you are given an equation and it asks you for the domain and range? What do you think you could do since you have a nice graphing calculator? Graph it, okay? So how do you get to the absolute value on the calculator? Who remembers? Yes. Math. Cursor over to, right, to NUM, and then just hit enter. You might want to write that down at the bottom. That is how you get to the absolute value bars. Okay, so I'm going to put a note, absolute value. Math, cursor over. So then all you're doing then is simply looking at your calculator. So they didn't put the graph up here for you. Okay, but they did give you what the equation of the graph is. It should be a V-shaped graph when you graphed it. How many people graphed this and got a V-shaped curve? Very good. So it should look like this on your calculator. Okay, so for your domains, your x values, you should have x such that x is an element of all real numbers. Okay. All right, so here's the graph, and then of course it's sitting right there on the axis. So your y values, like you said, would be y such that y is greater than or equal to 0. You can tell this, your y values are getting larger as the graph goes up. Okay. All right, so let's do the last one here. Go ahead and graph that one. I'll let you graph that one on your own and figure out what you would write for your domains and ranges. So go ahead and put it on your calculator so you can see what it looks like. Okay, after that, we'll be doing a different activity for classwork, and then you'll follow your calendar for homework.